Good day, I'm Dr. T and welcome to my dining room table. So today I'd like to talk about naming organic compounds, and the easiest way to do that is to simply start doing that. Now I'm going to draw these in a structure form that's not your standard structure. So it's going to kind of be an extended structure, but I'm not going to put the hydrogens on. This way we can easily see the carbons and the heteroatoms, but except for hydrogens attached to heteroatoms, I'm not going to put those hydrogens on, just so they don't get in the way. Okay, so let's take a look at this guy, and the easiest way to do it is just to start. So I'm going to start out with a molecule, and I'm going to have, say, 3 carbons. Pretty straightforward. Okay, so the starting out for all of these molecules is going to be the word alkane. But I'm going to start dropping a few things. Now, the first thing I'm going to do is I'm going to drop the alk, and I'm going to replace that with a Greek numeral prefix that indicates the number of carbons. Now, I will point out that for 1 through 4 carbons, like this 3 here, for historical reasons, there are unique prefixes. Meth for 1, eth for 2, prop, which is this guy, for 3, and bute, and by the way, it's pronounced bute, even though it's spelled but, bute for 4. Okay, so that's going to be prop. That's an E. That's the right answer. That's it. We've got ourselves a name. What we're going to be doing is the molecule becomes more and more complicated. We're going to have a more and more complicated name. We're going to start replacing things. But with a fairly simple molecule, hey, this is all we have to do. Okay. Okay. And so I could do a similar thing. Okay, I have 6 carbons there. I'll let you pause for a moment. The space bar or the K key allows you to pause on YouTube. So I'll let you pause and get a name for this guy. Okay, you got a name? Let's work on this one. Okay, 6. Greek letter for 6, or I should say Greek numeral prefix, is going to be hex. And it's going to end in A and E. That means I simply have a hydrocarbon. It's got single bonds, and that's it. Okay, hexane. Yay! Now, I will point out that occasionally you will see naming systems that are either predating or a little bit different than that of the standard UPAC names. If you are, say, answering a homework question, etc., it's going to be asking for the International Union of Pure and Applied Chemists name, or UPAC. But you may see this listed as in hexane. This part is not part of the UPAC name. And what this is doing is clearly indicating that this really is hexane, because in certain places what you will find is anything that has the formula C6H14 will be called hexanes. And the S on the end means you have a blend of isomers. The in hexane is clearly, no, this really is hexane. But once again, in UPAC nomenclature, you don't put the in on there. Okay, so let's make things a little bit more complicated, and there's a couple of ways we can do this. The first way is we can add a functional group. So let's go ahead and we'll take this guy, and I will put a double bond in here. Well, this is now no longer hexane. It's a different molecule. So what I'm going to do is it still has the same chain, still has the same number of carbons, so it's still going to be hex, but if you remember, a double bond, that functional group is an alkene, not an alkane. So it's no longer ALK-A-N-E, it's ALK-E-N-E. So now it's hexene. But there's a problem. That molecule exists, so does this one. And so does this one. Those are all 3 different molecules. Now, I will point out really quickly that this molecule is exactly the same as this molecule. Those are exactly the same molecule, as well as this molecule. Those are all exactly the same thing. This molecule has just simply been flipped over, and this molecule, that carbon, has simply rotated. Single bonds can rotate, so they're the same thing, even if they're twisted into a pretzel. Okay, but I have to name them because I still have 3 isomers. So how do I distinguish them? Well, I'm going to have to tell you where the double bond is, and there's actually 2 ways I can do it. For molecules that only really have 1 functional group, typically what we're going to do is simply slap a number in front of them. So for this guy right up here, what I will do is I will number my carbons going 1, 2, 3, 4, 5, 6, and this is on the 3rd carbon. So I would say this is 3-hexene. However, you will occasionally see it written as hex 3-ene. This way is more helpful if you've got other stuff on your molecule. So more complicated things, things with a 2nd or 3rd functional group, you typically see it in this fashion. However, if this is the only functional group on there, then you'll typically see it in this fashion. Okay, let's look at this one. So I can go 1, 2, 3, 4, 5, 6. So this makes sense that this would be 2. I'm just putting the first carbon that I land on, hexene. Double bonds, of course, stretch across 2 carbons. I picked the lower of the 2, or the first one. Now, what about this guy? I said these were the same. This would be 1, 2, this would be 1, and this would be 1, 2, 3, 4, 5. So is this 1 hexene and that's 5 hexene? No, I'm not writing them going from left to right. I'm writing them so that I get the lowest number. So when I number them, I go 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Now, I have 2 possible names, 1 hexene or 5 hexene. I pick the lower number. So this is 1 hexene. Whereas this guy, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. This guy is still 1 hexene because I picked the lowest number, not the one on the left. Typically, we tend to draw things on the left because, you know, that's the way we read English, but it doesn't have to be. Okay, so we've got our first functional group down. Now, next pop quiz for you. What would you call this guy? Once again, pause the video and we'll get an answer. Okay, let's go for this. Now, this is 4, so it's going to be bute. And that's a triple bond. What do we call a triple bond? An alkyne. So this is YNE for yne. And we need to indicate that is on the 2nd carbon, because 1, 2, 3, 4, 1, 2, 3, 4. It doesn't matter which way I go, it's in the middle. So that would be 2-butyne. Yay, we got ourselves a name. Okay, so later videos I will jump into other functional groups. The doubles and triple bonds, those are kind of the simple one. But with that said, I'll see you in later videos. Have a wonderful day.